Cross the rod. That's what I did! That's what I did! I was just like left with like nothing. I was like, what is this?
Alright guys, let's go through these. How'd you guys do on number 1?
Great.
1 more minute? Okay. 1 more moment, guys.
You don't have to do a coin flip, it's so funny.
That really is.
I never do coin flip. It's just coin flips for people who don't know.
Oh, shut up.
It's a bold move to just randomly walk in and
It really is.
coffee.
I mean, I applaud him. How do you know? I mean, is it a freshman? He doesn't look like a freshman. I know, I should ask him.
No one else like
The announcement about Thursday.
Wait. That's not a choice.
Honestly,
someone different identities. No, I meant like I thought.
All right, guys, we gotta start. Okay, so the first one, what is 1 minus sine squared?
Cosine.
Cosine squared, right? And tangent squared is sine squared over cosine squared.
wow.
Okay. Did we all get number 1?
Yeah.
Yay. Okay. How do we feel about number 2?
That was just rude.
I mean, no.
We got it, but it was rude.
Okay. You need a common denominator, which is going to be cosecant x minus 1 times cosecant x plus 1. What is that? I guess I could write it out so you see all this.
Cosecant squared x minus 1.
Yes. So this numerator is going to be sine times cosecant x plus 1. And this one will be sine cosecant x minus 1. Are we okay with that step? That's just finding a common denominator and writing it as one fraction. Okay. When I distribute the sine, what is sine times cosecant? 1. So I have 1. And then it'd be plus sine. And then again, sine times cosecant is 1. And then it'd be minus sine. So what do I have left in the numerator? And what is cosecant squared minus 1? Okay, we're trying to get to 2 tangent squared. What is cotangent squared?
1 over tangent squared.
Okay, you could do cosine squared over sine squared, or you could do 1 over tangent squared. So what happens when you're dividing by a fraction? So it's 2 tangent squared. And you're done. Squeeze it in there. Actually. Yay? Do we see it? How many of you got to like the 2 over cotangent squared and got stuck? Okay, so you're close. You're very close. All right, questions on that before we do our fake practice timed trig quiz? Oh. Any descriptors there? Any adjectives for you? All right, anybody still?
You got this. Can I grab this? I'll bring it right.
That's true.
Oh, 1 minute.
1 minute. 1 minute.
1 minute.
question.
12 seconds per question.
Like science.
12 seconds per question. Honestly, it's not. But I can think.
All right, guys, it's 5 questions. We'll start. The first few will just be sine, cosine, and tangent. Okay. All right. When I pass it out, just leave it upside down on your desk. No strategic mistakes, circles, no holding it up to the light.
What if you got a tattoo? Like, honestly. Look, they're not like this. Three, 6, 12 seconds for question.
I'm learning Spanish. I can't write it. I am not actually it doesn't matter how well I do.
I need to circle it. I can't do this.
All right, guys, clear your desk.
We need to take it on.
Wait, what?
Okay, kids are writing yet?
You told me to pass it to them.
All right,
Why not
guys.
do that?
Hold on. Oh, did you not get one ticket? Okay, hold on. We do have a couple people with extended time, so we'll.
That's me, right?
No.
Don't need one.
Sure, I'll give everyone a bonus.
That's gonna be it. That's gonna be it.
You get extra 6 seconds per question. All right, guys, ready?
Can we get another extra second?
Can we get one more extra second for writing our name?
Sure.
Can
Go!
we get another one after that? Oh my god.
I mean, it's a bad mess, but like, come on.
Shut up.
Ariel, eyes on your own favorite.
What?
Time.
What? In the world?
I have 16 seconds left. 16 seconds left. I don't know.
I got all of them except for wait.
All right, guys, second time.
I'm saying it's a second.
Okay, the second time. Extra time. Here we go. Okay, guys. I cracked up at the aggressive, like, pencil throwdown. I'm done. Funny for a lot of this. No, this is a practice. Fake practice. All right, guys, you want to check your own real quick?
Yeah.
What'd you get for number 1? Negative root 2 over 2.
That's
Yeah.
what I meant.
Okay.
I got that.
What about number 2? Root 3 over 2. Yes. Number 3. Root 3 over 3. Number 4. 1/2 and number 5. 0. For number 3, we can't leave it like that. It's y over x. Yeah, it's the other way. Yeah. 3 was root 3 over 3.
Wait for your break. Going on my academic.
This is number 3. It's a lot of 3.
Fair.
How'd you do, guys?
I got a B, technically.
Okay.
Better than your last. Listen, man, I can't do that.
Now you know what it's like.
I literally
Now we'll start real ones.
wrote my B.
I don't know if we'll do one Thursday. We'll see. We won't do one your first day back from winter break, though. I promise you that. Okay? We'll see.
Oh, I'm sweating.
All right, guys. Note time. It is. It is.
That's not like a championship level win, but that's like a playoff win.
I like it.
On my academic I'm a 5-star recruiter. You have 3 questions. You'll never be as good as me with 4. I'm a 5-star recruiter. By the time I get to the league,
Some different identities.
Oh.
I just didn't feel like writing all that. I'm going to write a bunch of it in. All right, guys, on to 6.2. It's sum and difference identities. That's what we're doing today. 4 identities.
I can't even remember the first ones.
Okay, well, we're going to add 4. There's sum and difference, double angle, half angle. Sum and difference are the most used, I'd say, out of those. Yeah. Well, Pythagorean identities are most used, then sum and difference, and then double angle. All right, the sine of 30 degrees plus 60 degrees, does it equal the sine of 30 degrees plus the sine of 60 degrees? Can we, like, distribute the sine? What'd you say, Jane? Sine of 90? Okay, yeah, this side is the sine of 90. And what is the sine of 90?
1.
1. Good job. What's happening on the other side? What's the sine of 30 degrees?
1/3. Sine of 30 is not 1.
Guys, you just did that. 1/2. What's the sine of 60 degrees?
Root 2 over 2.
One.
Oh my god.
Oh, boy.
Oh, okay.
Oh, boy.
So can we agree that they are not equal?
Yeah.
Okay. So if we want to evaluate sine of 2 angles, we can't just distribute the sine. Okay, we have these lovely formulas called the sum and difference formulas. Or sum and difference identities. Right. So first one, sine of A plus B. That is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. Uh-huh. Yep.
So much percentage.
Okay.
So we see it was wrong. But like, how does that pan out?
Oh, like up here.
Yeah. For the one that you equals 1, that's easy.
So it would be
That's cool.
so guys, this is what it looks like on the one up above here. Right over there, that says 60. So what's the sine of 30 degrees, guys?
That's cool.
1/2.
Yeah,
What's the cosine of 60? What's the cosine of 30? What's the sine of 60? You can't read that. So that's 1/4 plus 3/4, which is 1. Okay. Just to show you an example with ones that you know. It's up to you. We're going to do a bunch of examples with it, but that's like it does work. Just as like a this is how you use it.
Wait, so they are now.
Or is this always just?
Well, this one is because I
But
changed.
the other one was.
Right. I erased the. Okay. So let's do sine of A minus B because it is sum and difference formulas. It's sine of A cosine of B minus cosine of A sine of B. So that's not too bad. All right, then we have cosine, sum and difference. So there's we gotta do sine, cosine, and tangent. Okay. Uh-huh.
Just also be saying anything.
Tangent.
How do you get
Of course I don't.
go from like this to this?
How do I go what?
Like the sine of A plus B to the sine of A minus B.
So that's the next formula. Like if you have the sum of two angles, you would use the first formula. If you have the difference of two angles, you would use the second formula. So it's like, here's what you're given. This is the formula you use with it. All right, cosine, little different order. It's cosine A, cosine B, minus sine A, sine B. Yeah. So what I'm going to give you is I'll say, like, what's the sine of 105 degrees? So, like, what's the sine of 105 degrees? It's not on your circles, right? Okay. But you can make that with angles from your circle that you do know. So that would give, yeah, that's just to convert to radians. That wouldn't give you like the sine or the cosine or the tangent.
Would you add the 2 in parentheses?
Yeah, so like 105, you'd be like 60 plus 45.
Right. What if you don't think that fast? Like, what if you just like...
Okay. All right, guys, what do you think cosine of A minus B is going to equal?
Wait, or plus sine A, cosine
Cos B. No one has ever said it that way to me. That's really funny.
No one has ever decided to
Nope.
Why? Why did they... Why are they flip?
Why do you
It's cosine. Don't add them.
I'm not gonna remember this. I'm gonna mess this up so bad.
All right.
Can you curve them like cumulative?
No,
We get hurt.
you don't need it.
Yes,
It's not going to all fail. Hopefully none of you fail.
everyone fail on purpose. Just throw.
You know there are people that would not do that. All right. right, ready for the weird tangent ones?
It's going to be a fraction.
Well, I mean, it's,
like
there's a it's tangent, which is essentially sine over cosine, so we get fractions out of this.
Of course you are.
It is tangent A, bless you, plus tangent B over 1 minus tangent A tangent B. You guys are by far the most animated class while I'm writing formulas. Most people just write them down. You guys are like,
Listen, we have to. If we don't, then we're going to all pass out. Like, we don't want to.
all right, what do you think it's going to be for A minus B with tangent?
If there were one plus.
Okay, what about the numerator? Yep, tangent A minus tangent B.
An hour and 39 minutes break. Or an hour and 38. So you would do like 1 minute of class, a half break, and then 1 minute of class, and then
Class is only an hour and a half. We can't take an hour and 38-minute break in an hour and a half.
I'm thinking for an hour.
It includes the transition.
Apparently.
Math is relativistic effects.
All right, guys, there's your formulas. Woo, now we're going to use them. Good question. So if I give you a question with secant, cosecant, or cotangent, you can go through it as sine, cosine, or tangent, and then it's the reciprocal. Okay. All right, let's try one. Evaluate. Nope. Oh dear. Screen.
Well, I mean, I guess it's better than not.
Oh, I don't know. I just.
All right, let's do cosine of 15 degrees.
Oh, that's
All right, so 15 degrees is not one of the angles on our unit circle, right? Okay, but could you make 15 degrees out of two angles that you do know on your circle?
45 minus 30.
45 minus 30, let's do that. Sound like I'm... What are we, what? More proof practice.
Oh, actually, I do like the green.
Yeah.
I find it like this. I don't.
No.
Yeah, this cosine is 45.
yeah.
Unit circle gingerbread.
Wait,
That feels
yes.
like a stretch. I don't know.
Gingerbread unit
I got to fill out a unit circle on a gingerbread with icing.
Gingerbread Pythagoras.
Please.
Oh my goodness.
I beg.
All right, guys. So the way you go through this, you pick your two angles. The 45 is the A, and the 30 is the B, the way we've written this. You could use different angles. You could have done 60 minus 45. You could do 150 minus 135. You just have to pick things you actually know from your circle. First quadrant angles are the easiest if you know if it works with the angle we're looking at. And then you just plug it into the formula. So it's cosine of the first one times sine of the first one. Now it's cosine, so the sign in the middle is always the opposite of what you're doing. So since it's 45 minus 30, it'll be, oh, it's not sine. Thanks, guys.
See, I mean, you have to use. How are we gonna
I get confused. I just wrote the wrong one. All right, here we go. Sine 45 and sine 30. I was talking too much while writing. Sometimes that happens. Okay, better. Matches your formula. Okay. And now you evaluate. What is the cosine of 45 degrees? Oh, I know them. Do you know them on your truth quiz?
You think so?
What is the cosine of 30 degrees?
No.
Hey, Maddie, you
Literally
gotta know
no.
this.
Literally, that's your 6.
What?
That's your 6. That's not your 3.
Yeah.
So right.
It's a sine of 45 degrees.
It's like 1/2.
And 1/2.
That's your 1/2.
Okay. And then we simplify. So what's root 2 times root 3?
That's
Root 6 over 4 plus root 2 over 4. So your final answer is root 6 plus root 2 over 4.
Wait, you can't put those together?
Nope.
Why?
Oh yeah, let's do it.
I thought you could put the root over all of it.
How many
Right.
cups are
what?
7. So we're done with 1. Okay. Right? I don't know.
That's an almost
It's just plug it in and evaluate it. What?
There's like a 30-minute time.
I mean, a lot of it. Ignore the weird circle right there, guys.
No, it is. Foreshadowing.
All right, sine of 7 pi over 12. Stop. That's why the weird circle's there. Sorry, guys, my scrolling is really poor.
12.
Yeah, that's pretty dumb.
This up here, what is it? Stop harassing me in my life.
So you like
I think we should all get on.
split the denominator and put one of the denominators is 3, one of the denominators is 4.
Hold on, let me show you. Okay, so the over 12 part. You're used to seeing this as something, this is pi over 6, right? Pi over 4, pi over 3. What would the common denominator of those 3 fractions be? 12. So pi over 6 is 2 pi over 12. What's pi over 4 going to be? 3 pi over 12. And what's pi over 3 going to be? 4 pi over 12. Do you see any of them that you could add together to get 7 pi over 12?
4 and
Okay, you act like 4 plus 3 equaling 7. That's really hard, guys.
Wait,
Come on.
wait. So when it goes to the 1/2, of
That would be
of
6 pi over
Then
12.
where's the 5?
What 5?
Like 5 pi over 12 doesn't exist on the circle.
It's not one of the values that we actually know.
Right.
Just like 7 pi over 12 is one that we actually know. Yeah. All right. Do you guys want to try it?
Clearly.
No, you were just full of sass this morning.
that's because, yeah.
That's because, yeah.
That's all right.
All right, I'll give you a minute to try.
I'm actually done. Too early.
And it doesn't matter with adding if you put the pi over 4 first or the pi over 3 first. You'll get the same answer at the end. Check when you're ready.
Look over there. Isn't it ugly? Wait, what?
I'll
You
explain.
need to stop.
Is that?
Because we just.
Oh, I'm just dumb, see, if that's what it is.
We didn't.
I don't know where it all came from.
It's not.
You're like, it didn't work. My thinking cap is not functioning today.
I literally just dumb mistake on my life. I'm not.
I think it's just like this one.
You see it?
I'm not the last.
You guys just get it.
Herbert's already with the
It's gonna be short.
You speak a little Vietnamese, but okay, what
There is, if you're willing to think.
It's root 15 and 7. I'm not easy.
Let's think about it. All right, guys. We get the same answer, right? Okay, let's think about why we do that. So cosine of 15 degrees, that's 15 degrees up from the x-axis, right? And if it's cosine, I'm talking about the x part of, like, that coordinate. 7 pi over 12, where is that? It's in quadrant 2. It's a little bit past 90, right? It would be 15 degrees past where 90 is. And it's the sine. So now I'm asking you for the y value of that. So it's essentially the same angle, just like cosine of 30 degrees and sine of 60 degrees are the same thing. Cosine of 15 degrees and sine of essentially 105 degrees are going to be the same thing. All of these that you do with sine and cosine will be some combination of a root 6, a root 2, and over 4. They might be negative root 6 minus root 2, negative root 6 plus root 2. You can think through it and figure it out without doing the formula if you understand what creates like a longer side and a shorter side. That's not easy for everyone to do, so that's why I give you the formulas. But there is definitely a shortcut way to just look at it and go, okay, cosine of 15, that's going to be the longest side possible, positive. So root 6 plus root 2, that's going to give me the biggest numerator possible. That's why that's the answer. If that's like overwhelming your brain, you can certainly just do the formula. Yeah. Yes. Yep, same thing. So again, any sine and cosine, if you get to the end and you've got like root 5 plus 7, you did something wrong, okay? It will be some combo of root 6, root 2, and over 4. Tangent will not be. Tangent's different, of course. But sine and cosine will be that.
So technically, I just guess.
Yes. Or, like, logically think through it.
I don't.
That's what I'm talking about. So, like,
Well, like, could I
15
do, like,
degrees over here, you see that's like the longest x we're going to get. That's why that's a positive root 6 plus root 2.
Oh, gotcha. Okay.
Whereas, like,
Yeah.
the other one we did was up here. Do you see how that's like the longest y?
Yeah.
So the sine of it was that.
Okay.
If you're down here, you're going to have the biggest negative one.
So,
So that's going to
negative
be
6 minus root 2.
exactly.
Oh,
It's kind of interesting.
okay. I'm on board with that.
Good.
The tangent's just different.
Tangent special. Let's try a tangent. All right, tangent of 105 degrees. Okay, I'm going to help you pick your angles for this, because there's different angles you could pick for sure. When you're doing tangent, avoid the pi over 6s. Okay? Because the tangent of pi over 6 is root 3 over 3. It creates a lot more work for you to do than if you pick, say, the tangent of a pi over 3, which is just root 3. Okay, so please avoid, and in degrees, I'm talking avoid the 30 degrees. Okay, so can you make 105 degrees avoiding the 30 degrees or the 150 degrees? What do we want to use?
45 is still there.
Yeah. Yeah, what's up?
So what if we split it up into like 30 and 75? If we first add 75 together and then add 30 together.
So you want to do like a bonus problem within it?
Yeah, sure. No, if it comes to that, like, because I need to do that, would it be?
You won't need to do that. Don't do that. I mean, you could get there, but you're going to have like
It's a lot of
insane simplifying with radicals, because you're going to get like 1 plus root 3 over 1 minus root 3 that you're now going to plug into another fraction. Yeah. Pick things you know. All right, so tangent of 45 plus 60, that's going to be tangent of 45 plus tangent of 60 over 1 minus tangent of 45 times tangent of 60. Yeah.
Would you ever give us something that just like
That you can't make out of things you know?
17 or something?
No, I would not do that. It's going to really be increments of like 15 degrees. That's what it'll be. Yeah. So what is tangent of 45? 1. What is tangent of 60? Root 3 over 1 minus 1 times root 3. What? I mean, not really. So your numerator is 1 plus root 3, and your denominator is 1 minus root 3. Okay? We're going to rationalize that. That's it. You're done. No. Oh, no.
But then you're stuck alone.
No, you're not. All right. What do we multiply by here? 1 plus root 3. You got to do the full conjugate here.
That's why I got stuck.
That makes sense.
Wait, Miss Billy,
Yes.
why do we do 1 plus root 3, but not say like 1 minus root 3?
So you look at the denominator, and you're going to change whatever the sign is in front of your square root. So it right now is 1 minus root 3. The conjugate is going to be 1
You do
plus.
the
Yes. All right, so when I multiply out the numerator, I get 1 plus root 3 plus root 3 plus 3. What happens in the denominator? Hopefully something. We picked that number on purpose. 1 minus 3. Yes. The radicals are going to cancel out. So in the numerator, I have 4 plus 2 root 3. And in the denominator, I have negative 2. So what is my final answer?
Negative 2 plus 3.
Close. Yes. Because you're dividing both of those by a negative 2. So just like the sine and cosines are all going to be some combo of positive or negative root 6 and root 2 over 4, your tangents are going to be 2 and root 3 once you rationalize at the end. Negative 2, positive root 3. Okay?
We also want to do things not
You
really.
could, yeah. All right. Are you ready for an easier one?
Yes.
Okay. Anybody questions on that one before we okay? We get it? Okay. All right, this one's sine of 80 times cosine of 20 minus cosine of 80. This is easier, I promise.
Oh, isn't that just one of the formulas?
That is just one of the formulas.
Oh, so is it just cosine of 100? Or no, it's sine of 100.
Yeah, is it the sine formula or the cosine formula? Sine, and is it up angles plus or angles minus? So this is really the sine of 80 minus 20. Well, what's 80 minus 20? And what is the sine of 60? I heard it, root 3 over 2. So that was easier, right? I did not lie. All right, questions on that one? If you see it all written out with weird numbers, it's probably, here's the formula you're working backwards, okay? You clearly don't know the sine of 80 and the cosine of 20, and don't try to like add angles together to get that. That's not what we're wanting there, okay? All right, let's try again.
What's an X?
Alpha minus beta.
Oh, it's fish.
It's a fish.
How do you...
Sine of the fish. Okay, great.
No, that's just like a day.
Sine of alpha. Sine of beta. Beta. Beta's like a weird beat.
Can I just like draw things?
Sure.
What is this? What is this? So many weird things are going on this slide.
I use all
Will's gonna regret his decision to come back.
I just
No, it's not that bad. It just looks weird writing it down, but it's actually a pretty simple proof.
A and T.
Yeah, I just didn't want you to never see alpha and beta and then it show up somewhere and you'd be like, what? So I'm showing it to you. I know.
I took it instead of gym.
That's just a discount A and B.
A discount.
Although like that's Greek English as well, so
It's like the original A and B.
exactly.
All right. Everybody got it written down? Almost? No. It's just different letters.
Can I just change them from alpha and beta to whatever? Or did they have to read beta?
You need, if you're gonna switch them, you need to like tell me you're switching them. Like let alpha equal A, let beta equal B, that sort of thing. And then stay consistent. It can't be like alpha and beta in one step, A and B in another step, X and Y in a third. Like, no. All right, so this is a proof, but the sum and difference formulas are just going to guide you through the proof, okay? So they help you. We're going to work on the left side. That numerator, cosine of alpha minus beta, we could expand that into our formula for cosine of A minus B.
Would that be helpful?
Yes. You will see in a moment. So cosine is going to be cosine alpha, cosine beta.
Oh, it's like one of the formulas.
Plus, yeah, it's your difference formula for cosine.
No, like the Oh, wait.
Easy.
It is.
Because cosine over sine.
Oh, it's tangent?
Yeah,
Or,
so
yeah, it's cotangent? Yeah, we'll get there eventually.
So you split up the denominators, and then that would equal +1, and then that would equal +6.
We've got like 2 steps left on this one. Right, small. It'll fit. So guys, I can now write this as 2 separate fractions, right? The cosine alpha, cosine beta over the denominator plus sine alpha, sine beta over the denominator. You can split it apart, okay?
Oh, I see where this is going. I see where this is going.
We've now gone to cos fish. Is that what I'm hearing?
You wrote cosine alpha sine b.
Why do I keep wanting to write sine today, guys? I don't know.
Fish.
Fish. Okay. Okay, there we go. Do we see it? Yes. So cosine alpha over sine alpha is going to be cotangent alpha. You got to have the same letters too, okay? Alpha over alpha makes alpha. So cotangent alpha. What about cosine beta over sine beta? Cotangent beta.
How are you allowed to like split it up?
So if I had like 3 times 2 over 5 times 7, that is 3/5 times 2/7, which is what I did. Because I did cosine over sine times. Right. Okay, and then sine alpha, sine beta over sine alpha, sine beta is 1. And we're there. 2 problems left, guys. Questions on 5? It's like a 3-step proof.
So basically the same as question 5.
But no fractions, so a little less. Okay. All right, try this one, guys. Sine of 5 pi minus x equals sine of x. You're going to work on the left. Give it a try. Yeah. Aiden sees something. Mm-hmm. Could you graph it? I mean, yeah, but that's not really how we're going to prove things. But technically, you could graph it. The period would be 2 pi over 5. And, well, actually, no, the period would be normal, but you'd be reflecting over the y-axis and then shifting by 5 pi.
But would they have to be the same?
Yeah. You could do that. I mean, for fun at home, if you're like, oh, I'm going to graph them and see if they match.
No, so it's 1, 2.
You could. Aim's like, that's not fun at home.
I'm like 75% completion.
Did you get it? Yeah.
What is sine times does it not matter?
Well, no, it's like sine of an angle and cosine of something, right? Or cosine of an angle. Ooh, look at that. Do you have like a sine or cosine of 5 pi in there somewhere?
Yeah.
Okay, evaluate that.
One way around.
If you're on sine 5 pi, cosine x is minus cosine 5 pi. Sine x is plus cosine. Everything is x.
How we doing, guys? Did you get there though, Maddie? Yeah, see? Are you ready for me or you need a minute to fix?
We're just gonna like search them and pretend I know what I'm doing. Because I know how to do it. I just messed it up.
Oh, sign.
All right, let's look and see if you
Then
can find it.
what do I do it? What is
Jane, did you just say sign?
I get it.
Instantaneous.
All right, guys. Step one is you expand with your formula here. So it's going to be sine of 5 pi cosine of x minus cosine of 5 pi sine of x. Everybody okay with that? All right. What is the sine of 5 pi? 0. Okay, so I've got 0 times cosine, or you just can say that's gone. Minus, what is the cosine of 5 pi? -1. So 0 times cosine is gone, and minus -1 is, yeah, so this is just sine. All right, let's stop for a minute, make sure we're okay. What's the sine of 5 pi? So like 1 pi, 2 pi, 3 pi, 4 pi, 5.
I'm actually dumb. That's the answer. I was like, I don't even ask what I was doing because it was sad.
All right, I won't ask.
I was with the rest of it.
Bye, Bridget. Okay, guys, one more. Almost. All right. Okay. It's not as bad as the initial writing of the formulas made you think it was.
As long as just like these problems, I don't put unnecessarily complex numbers.
What? What? Just write it all and then I'll explain.
What in the world?
Patience, people.
Literally over here for
You're not wrong. Clear that up so you can see.
It's the Jesus fish. I just clicked that. Because it's a Christian symbol.
Alpha.
Christian fish. I'll never see the same now.
I'll show you in a minute. I need to move them up a little. Another line somewhere. Okay. Everybody have it written? Okay. So you are given information about two different angles here. You're given an alpha and a beta. We know the sine of alpha, and we know where alpha is located. When it says 0 is less than alpha is less than pi over 2, what quadrant am I talking about? First quadrant. So we're going to draw a little triangle in the first quadrant. This is my alpha triangle, okay? Sine of alpha is 3 over 5. So opposite is 3, hypotenuse is 5. What will the other side of that triangle be? 4. Okay. We also have to draw a separate beta triangle. That's why I got another little spot there. What quadrant is beta in? 1. So both being in the first quadrant is simpler because everything's positive. if you move to the second, third, fourth quadrant, you have to think about what side might be negative. Is the hypotenuse ever negative? No. Okay, just making sure we got that. All right, so for beta, we know the cosine of beta is 5 over 13. So adjacent is 5, hypotenuse is 13. What is the other side? 12. Okay. That's using the given information. Then I have to actually ask you a question. We are going to find the sine of alpha plus beta. Go ahead, Nick.
We have sine of alpha is oh, those are two different triangles.
Two different triangles. We got an alpha triangle and a beta triangle. It's taking all that given information and putting it in the pictures. Do you see it, or are you stuck on something else? For sure. Josh, you okay? Okay. All right, so find sine of alpha plus beta. We need our formula. What am I going to write? Sine of what?
Yep. Yes.
Sine of Cosby.
And then also sine
Plus what?
It's actually hard to say it like that.
Hey, if you guys remember it that way, that's great. I don't care. It just cracks me up. Usually we give you like a formula part of the test where you have to fill in the formulas and you get graded on that, and then I give you a formula sheet to use on the test, because if you screw up one of the formulas, you're going to miss every problem with that formula. So I'd like to separate your knowledge on knowing them and being able to use them. Yeah. All right, once you have your formula, you're now going to fill these in, not from your unit circle, but from the triangles you drew. Okay, so what is the sine of alpha? 3 over 5. What is the cosine of beta? Okay. Plus, what's the cosine of alpha?
4 over 5.
4 over 5 times, what's the sine of beta?
12 over 6.
Good.
It's a lot of numbers.
And now we math. So what's 3 times 5? 15 over what's 5 times 13? 65.
That's too chunky.
Now, you could reduce that, but we have to add fractions and we need a common denominator, so don't reduce at the beginning. It's one of the rare times where I'll say don't reduce right away. And then the next set of fractions, what's 4 times 12?
48
Over.
65.
Okay, 15 plus 48. 63 over 65. That is your answer.
That's
That's
it. That's what we're doing right there.
That's it. You made it. Poor Aiden, just left you hanging there. All right, guys. Let me make your math space available real quick, but that is the end of notes.
Are we gonna get our test back?
Yes. Let me make this open first, and then I'll pass it back.